Sometimes these functions, our functions are not going to be continuous, and they're going to be discontinuous at some points. That means that the limit when, so the limit when x goes to a of f of x is not going to be equal to f of a, okay? Or if a is not in the domain, it could be the case that the limit when x goes to a from the right is not the same as the limit when x goes to a on the left, okay? So for instance, let's see, we have f of x sine of x over x, right? So this function is continuous in all points except 0, right? Because 0 is not in the domain. But what happens at 0? Well, the limit when x goes to 0 of the sine of x over x, we know it's 1, right? So if we define this function g of x as the sine of x over x when x is different than 0, and 1 when x is 0, then now we have a function that's continuous in the whole of the real line, right? So we have took a function that's not continuous at one point because it's not defined there, and kind of like put a point there, and with that we have kind of completed the function and made it continuous. Okay, when that's the case, we have what we call let's call them avoidable discontinuities. Okay, and that's discontinuities in which you have like something like this, a function like this, and then it has a hole here. It's not, this is not this function, okay? Any other function. And this in here, the function f, this is f. F is not defined here. Okay, so if when that's the case, we can redefine a new function g, which is f in every point except in this hole, and then the value of the limit at this point, and then that new function will be continuous. And that's why what we call it avoidable discontinuities. Okay, let's see another kind of discontinuity. We have, for instance, the Heaviside function that we have seen, okay, which is 0 if x is smaller than 0, 1 if x is greater or equal than 0, right? Now this is the function that it goes like this, and then boom, right? And it does a jump, right? At 0, it goes from 0 to 1, and here we can't avoid it, right? There's no way we can define something at 0 with, you know, for instance, a value of 1/2 for the Heaviside function. It won't make it continuous because the limit from the right, you know, when you go to 0 from the right, and the limit from the left will never be the same, right? In this case, we call them jump discontinuities, okay? Because that's what the function does. It jumps from one value to the other, okay? And that's when the limit on the left and the limit on the right from one value is not the same, okay? And the last type of discontinuity are what we call singularities, which are points where the function is not defined, and it's not only a jump, it's that it goes to infinity, okay? The classical example for this is 1 over x, as we have seen, okay? The limit when x goes to 0 from the right of 1 over x is plus infinity. The limit when x goes to 0 from the left of 1 over x is minus infinity, okay? It's not only that there's a jump here, it's that the limit is infinite, okay? It could also be the case that if you have, for instance, 1 over the absolute of value of x, you have this thing, right? It also goes to infinity in both cases, right? this is also a case of a singularity, right? Because at 0 it's not defined. Okay, so that's the 3 possible values of discontinuities, and well, also the fourth case, but this is less common, is that there is no limit at x equals a. So, for instance, as we have seen, the limit of the sine of 1 over x, well, the limit when x goes to 0 of this doesn't exist, right? We have seen, because this function does something like this and then starts to oscillate a lot, and then so this is 0, right? And it keeps oscillating, but around 0 it goes like this. Yeah, the oscillations increase in frequency further and further, so there's no limit there. Okay, so in that case, what we have is a different kind of discontinuity, because there's no limit. Okay, so related to this, there's this exercise, that I gave you. This function f of x is x times the sine of 1 over x, and I ask you what kind of discontinuity has this function at 0. Okay, this function is not defined at 0, right? Because the sine of 1 over x is not defined at 0. What is the discontinuity? What kind of discontinuity of the 4 types that we have seen before? Okay.